Okay. Hello, everybody. Welcome back to Intro to Backend. This is the seventh demo for authentication. And I guess to recap the lecture that we talked about last week, or those recorded last week, to authenticate into like your API, you can have people log in with a username or email and a password, and your backend will authenticate that password and can keep track of the user in multiple different ways. The first way is by having them send the password for each request they make so that we can tell that they're the correct person that is making the request. The second one is using cookies. We can actually store their session as a cookie, like a random string of letters, put it in their browser cookie. And the third way is by saving those session tokens in a database, which is called HTTP token. And that's the one that has the least downsides. And this is what we're going to demo today. So to go over HTTP session tokens, when you log in to our API or you make a new account, what happens is that the backend will send back a session token, which is a random string of letters and numbers. And that token, if you send it back to the backend API, will authenticate you into that user. So if you wanted to make a post as user2 and you send the session token along with the post, then the backend can tell that you're actually the person that owns that account. And these sessions can expire so that if you somehow someone finds your session token, they won't be able to log in for too long because it'll eventually expire. And once it expires, you can either re-log in with your password or you can use a secondary token called a refresh token that refreshes your expiration date on your session token. And it'll just like give you a brand new one. We're going to go over that in a bit more depth here. So let me put this on. Okay. So here's a pretty simple backend from like PA4. We can register our account, log in, log out. And for our database, we have just a user table, as you can see here. And it has the email and password. It's called a password digest here because it's not the actual password in like plain text. It's actually hashed so that if someone gets your database and can read out all the entries, they can't read out your password because it'll be hashed. And it's not, you can't decrypt the hash. You have to actually guess what password hashes to that one. And we'll talk more about that when we get to hashing the password. But this just means that, well, it's like a password like column, it's just a string column. We're not going to put the plain text password in there. Some other fields we have are the session token. This is just a normal string field. This is going to be the token that we use to authenticate a user. We have the expiration date of the token here. This is just a date time, and this is the time when it'll expire. So once we go past that time, the session will be invalid. You have to make a new one. And here's the refresh token, which allows the person to refresh their session. So just make a new set of tokens. And this can have a expiration date if you want as well, because the same reasons for the other one. And we have one extra file here called the users DAO. This stands for data access objects. And it just has a bunch of simple functions that we can write to make accessing certain like objects easier, like getting the user by an email, getting user by a session token, and so on. And we're going to start off by finishing the db.py or the user model. So if we want to make a new user, we will pass in like our email and password. So this would be like normal. So we just like let's see, email, or actually self.email equals KWARGS, or get email. And then password will actually be something special. So if we do it like this, it's just going to store the plain text password. So we want to hash this password somehow. And we have a new module we installed in requirements called, where is it? Bcrypt. And this has some methods for hashing and then verifying hashes and so on. So with the bcrypt module, we can say, we put this over here, bcrypt dot hash pw. And this takes in the password you want to hash. And the one thing to note is that the password actually has to be like a bit string or like a bytes, it has to be a bytes object. And you can do that by saying encode and then UTF-8. So this will encode a UTF-8 string into bytes. That's just what this function requires. And one other thing we're going to add to the hash is a salt. So bcrypt gensalt. And this will like, so like a hash is like a random string of bits that you can, it's like a one-way function from plain text like password or any string into a set of bit or letters and numbers. And if you have like this set of letters and numbers, you can't decrypt it back into the plain text password. So, but you can if you like get this letters and numbers string, try a bunch of passwords and see if they equal the hash. And to try to avoid that, we append like a salt, which is some other random letters and numbers. So we're gonna randomize it 13 times. And this will make it harder for people if they get your hash password to guess what password fits on it because they always have to guess the salt because they won't equal what we will have in our database because we added something onto it. Yeah.
Well, just a few challenge, challenge to like the rounds 13 is hidden in the environment of where should we do that?
I don't think you need to because it's just like having more rounds makes it takes longer to hash it. So more rounds makes it harder for them to actually guess a password because each time you try to do it, more rounds is like I think doubling each time. It's not like something you have to keep secret, I believe, because the actual hash like salt is randomized. But having more rounds is better, but it makes it slower to make these hashes. So it's like trade-off between how secure you want it versus how fast you want it. And yeah, this will make our hash password. We'll store that into our database. And for the tokens, we're going to make a function called renew session. Self.renew session. And this will renew our sessions. So let's write that function real quick. Let's scroll down. This will just so for like session token, we want to be just a random set of numbers and letters. It doesn't have to be a hash or anything. So we have a function here called URL safe base64 that will make random string. It'll hash it with SHA-1 hashing function. And it's going to turn it into a hex string. So it's not obscenely long. Because when it says random 64, it's a 64 bytes of bits randomized. So this will just make a random hex string. We can just use that as like a helper function. So URL. You want to make sure it's like sufficiently randomized and not in a predictable way, because some random functions aren't good for cryptography. I think this one might be better. So we'll have our session token be this a random string. Our refresh token will also be this random string. Oops. And our expiration date is going to be a Python datetime object. So datetime.datetime.now. And let's say for this project, we want to expire 1 day after it's created. So with datetime objects, you can add something called a time delta. So it's datetime dot time delta. And let's say the change in time from that we're going to add is going to be 1 day. So we're going to add to right now plus an extra day. So this expires tomorrow at this time, whenever we create it. Okay, looks good. Next, we're gonna try working on verify password. So if someone's logging in, they send their, yeah, where does it update token? Oh, they're just like yours. It updates your session, refreshes your session. This is the terminology using the lecture was refresh. I think it might have been updated in the past. Yeah. So yeah, if someone logs in, they send their plain text password, and we get that as password. We want to verify that it's the same password in the database, but in hashed form. So in order to do that, we have to actually hash our password and then see if it's equal. But bcrypt has a function for this. That's called check password. And it just takes in password and it has to be encoded in like a byte string the same way as the original password. So encode UTF-8. And then we need the actual hash password. So self.password digest. So this will just, what this function will do is hash the given password and then see if it's the same as the password for that user. Now, if we want to verify if someone's session is correct, then there are two things that have to be true. First off, the session token that's given must be equal to the session token in the database. And also it can't be expired, right? So date time. Now we want the current time to be less than the expiration time. So self.expiration. That's not right. I'll just copy this, but yeah, so the current time has to be before the expiration time. And if these two are true, then the user is valid, they're valid user because they have the right session token and it's not expired. For refresh token, it's the same, but in this example project, it doesn't have any expiration time. So you can just check if it's the same. Okay, so does anyone have any questions about what we did in this file or anything about these tokens or hashing passwords or anything? All right, so before we work on the routes, we're gonna work on the DAO, the data objects, data access objects. These are just gonna be like helper functions for our routes. So for like get user by email, it's pretty simple. We will just return user.query filter, and where the user's email equals the given email. And since filter returns a list of users, this should have only one user, since we're gonna have unique user emails potentially. So we want to say dot first to get the first one. For getting user by session token, it's the same. Instead of just using the email, we use session token. And the same for refresh token. I guess there's one more thing we can do with db.py. We can have an extra field called, I guess, first name. And it's just going to be like the user's first name so that we can see for a good example for like a privileged request. So first name. It's good. So the next function is going to be verify credentials. This is going to be when in the login endpoint, they send their username and password. This is just going to use the functions from db.py. But I guess the issue, there's only one issue is that the reason why we can't use like verify password directly is that we don't know if the email they give us is actually in our database. So I think we're just going to actually start with app.py. And we're going to go to these DAO functions later to see why we need separate functions for those. So here in app.py, we import our user's DAO. We import DB, request, Flask, all of that. We set up a database called auth.db, just like a PA4, all the same stuff. The difference comes when we have functions like extract token, which will extract the token from requests. We have register account on a register endpoint, login, log out. We have a function session for updating our session. And we have a secret endpoint that you can only access when you're logged into a user. This can be like this can be similar to posting your story or something. So let's start off with register. So like with any other post request, you want to get the post body. And so just be loading the JSON and the requests data, just like normal. And when someone registers an account, they're going to give us their first name, they're going to give us their email. They're also going to give us their password. And if first name is none, or email is none, or password is none, then the body's invalid. We're just going to return the JSON dumps error invalid body or invalid post body. I guess just invalid body. So now we have their first name, email, password. Now we want to create the user. And I know, I'm going to check on what's up. So we have a function in the user DAO called create user that we're going to use. So user DAO, create user. This will take in the first name, email, password. And let's actually just implement this real quick. Let's add this to the function bot name. So if we create a user, we want to actually make sure that that email isn't already in the database, because if you make an account on a website, you can't just steal someone else's username or email, right? So if we type in possible user, this will equal get user by email. And this will check if that user is in the database. If possible user, not none, then someone already has that email. So we'll return false. We'll also return the user that we found. This will be used by out.py. So if it is none, then we can make that user. So using the user model, we can give it the first name, email, and the password. And then we can say db session add user db session. Nope. And then now it will be in a database. we can return true, and then the user we just made. And we're passing in the plain text password. This will go into db.py. It'll be going in it, and it'll be hashed here, as we did before. And then the database will only store those hash passwords, which are more secure. Yeah, if you want to take pictures right there. Okay, so yeah. Go back. So the output of create user is a tuple. It returns the Boolean. We can say created, and also returns a user with that. And you can unpack tuples by just saying, putting them in like comma separated. So like here we return false comma possible user, true comma user. So we can set that equal to created comma user. Just something cool that Python does. So if not created, then there must have been some sort of issue. Let me go back here. The issue that we put in our DAO file function was that user already exists, so we can just return error user already exists. And otherwise, we can just create that user, or that user already created. We can just send back the session tokens. So we'll return based on dumps. Session token. Oops. I don't know why this giant block shows up. User.session token. Run session expiration. User.session expiration. Then refresh token. User.refresh token. So we send back the two tokens and the expiration date back to the person on Postman or the client using our API. And this will allow them to authenticate themselves with their tokens whenever they make a request, which will make it more secure because they're not going to send their passwords over HTTP anymore. They'll just send their session token. It's better than having your passwords found when you're sending it. Does anyone have any questions? Yeah. Yeah, so in create user, you return true comma user or false possible user comma. It's like you can put parentheses around it like that, but Python doesn't require you to. So then when you set something equal to this function's output, you can unpack it like that, just in the same format. So it's kind of like matching the pattern. Yeah. Let's quickly test this out. So this is a post request, and then we can go to /register. And we can just give it our information, right? It takes in a first name. This is going to be Caduce. Email. Test at gmail.com. And then a password. So be password 2. My real password, genuinely. And I did forget to run the server, so you will not pay for it. Hopefully this runs okay. Okay, cool. Take some one. Where is this happening? User first name. Let me go to user minutes. Oh, I messed this up. Oh, yeah. So we're using keyword arguments for an init function. So I actually do have to say when you're creating the user objects, first name equals first name, email equals email, password equals password. And then it can actually find those as keys that we use here. I think I made a mistake with one of the JSON objects. This happens line 44, this app.py. It's not JSON serializable. Oh yeah, this is a datetime object, but we want it to be a string. So we have to cast this to a string so that JSON can put that into string format. So hopefully that works. And it did actually go through multiple times. So let me make a new user. I don't know why it's so slow. So this worked this time. And now I have my session token, my expiration date, and my refresh token. And now let's try logging in. So the register account logs you in when you register a new account, but if you already made an account, you can't register it again, right? Because it says it already exists. And it'd be a waste of time. So let's implement logging in with your email and password. So this will be the same, a lot of the same as registered. So we'll copy these inputs and get rid of the first name because you don't need the first name to log in. Only the email and password. And so this, I didn't use it yet. We'll copy the if it's none part. And just get rid of the first name so that they have to send their email and password. And if not, invalid body they get. And then now we're going to use another DAO method called verify. Wait 1 second. Users DAO dot verify credentials. And this takes in their email and password. And I guess the one thing that might be confusing with this is that why not just use verify password? So like some separate function in the DAO, right? Because we don't actually know if this user with this email exists, so you can't get the user object. So we'll use a separate function to get the user object first, and then we can use that verify password function. So in verify credentials, we'll do just that. Go to this. It'll be like create user where we don't know if this user exists or not. So possible user equals get user by email. So we might have a user, we might not. So if possible user is none, then that's bad. This user doesn't exist. So we'll return false. And then we'll just return none. So we weren't able to find the user, but you can't log in. However, if we do find a user, then we can return possible user, not verify password, and then password. And this will use the db.py verify password function that checks the hash and sees if that works. And then we'll also return possible user just for the serializing. Verify password returns a boolean. We go back to that. So this just checks the password and codes it into bytes, then hashes it, then checks if it's the same as the other hash in the database, and returns true or false if that is the correct password. And then we'll also return the user. So yeah, that just checks the credentials and sees if they're right. So the output would then be success the user. So if this was a success, or if this was not a success, then we can return an error response. And invalid credentials. It's pretty good not to tell them if they got the wrong email or wrong password because you don't want to give anyone any hints like that. So just saying invalid credentials is pretty nice. Saying just invalid password means that they got the right email username. Saying invalid username means they got the right password. That's even worse. So just making it as vague as possible is the best, probably the best way to do it. And if they did get the right credentials, then we're just going to return. We actually have to return screen. Yeah. We actually have to renew their session because in the database they have session token, refresh token, and expiration date. So if they log in multiple times, they'll get the same one. You want to reset it. So we'll use user.renew session. This will just change up the session tokens, randomize them, and give them a new expiration date. And then we can return based on dumps. The same thing we return in register, which is just their tokens. And they'll be brand new. If someone had your session token before you logged in, it will be invalid once you do log in because they'll be randomized again. And yeah, this is very important. So you don't get the same token every time you log in. So I don't have any questions about login while I test this out. Okay, so let's try logging into this account. We don't, let's make a new endpoint. Again. Raw email would be tests@gmail.com. Password 2. This will be JSON format. And I actually got the token. If I give it a wrong password, no clue why it's so slow. I get invalid credentials. So it's working as intended. That's pretty nice. Oops. So I guess next up is logging out. If you log in, you might want to log out. It's pretty self-explanatory. And the way this works is so the next 3 functions actually require you to give in a token. And the way you pass your token into our API is with an authorization header. So headers are just like extra metadata that you add to your request, right? If I go to headers here, you can actually see what's enabled. So we have like content type, JSON, hosts, user agent. In Postman, if you click authorization and click bearer token, that's what we're going to use here. And here's an example token that I had from before. It adds a new header right here called authorization. And here is the actual token. And bearer tokens put the word bearer in front of it, just a way to know that it's a bearer token. And this is how you'll normally pass like API keys or session tokens to APIs in real life. So yeah, here's how you actually get that in Flask. You're gonna make a new function called extract token, and this will take a token out of your request. So this takes in a request object. And we go up here. We want the auth header. And this will equal request. Normally we've been using request.data all the time, but now we're going to use request.headers. And this is just another dictionary. So we can say request.headers.get authorization. And that'll give us our authorization header. If the auth header is none, no, we actually didn't pass anything in. So return false. And then we'll just JSON dumps some error message. Error missing auth header. If we do have a header, we want to make sure it's a bearer token, which has the format bearer and then token. And this is going to be a string. So we can say bearer token. There's the auth header. And you can use a Python function replace and replace the word bearer with the empty string. Now I'll get rid of the word bearer in the string. We'll use strip to get rid of any white space at the ends. So we just have a token. And we can also check if that is still not none. So bearer token is not none. Or you can just say if not bearer token. So just catch all. And we'll return false. And we're just gonna copy this. And we'll say instead of missing, we'll say invalid. Now we have a bearer token. That's just our actual token. So we'll return true and then bearer token. And this is how you're gonna get the token every time you wanna actually get it from the authorization header. So for logout, we're gonna get that token. So success, and then for logout, we want the session token. So we'll call it session token. And this will just extract token from the requests like that. And that should just give it to us. If not success, then return session token. Because the extract token returns like error messages, this will have an error message in it. So we'll just return that as an error message. I guess we can say response. If not success, return response. Otherwise, session token equals response. Does that part make sense? Or we just get the response. If it's an error response, return it. Otherwise, put it in the session token. That's our token. Okay. Now we're going to use our user DAO. So user is users DAO. And we have a function get user by session token. And we'll just pass that in. Now we have our user. But this function only checks if that user has a session token. It doesn't check the expiration. So we'll check that right now. So if not user, if there isn't a user, or not user, verify session token. So check if it's expired. Then we'll return, return based on dumps, error, invalid session token. What's going on down there? Yeah. And now we have our valid session token. So if we want to expire a user session, we want to log out from a user, then we'll just expire the session. So user.session expiration will be set to right now. So we'll just expire it. And now that token will not be usable anymore. So let's save this. And then return just some message. Message. You have been logged out. Nice. We're kind of running low on time. Does this part make sense? I think we can just test it out really quick. Right now I'm logged in. I'm not even running the code. I'll log in real quick. And so if I want to actually use logout, I need to copy this token. So copy this. And then I want to go to the logout endpoint. So post logout. And I'm going to put this in my authorization tab, go to bearer token, and then we'll put this into here. And you can check your headers, scroll up, and you can see it's right there. So if I send this now, It seems like it's invalid. It's weird. Let me log in again. Here's a token. Place this. I think there might be an error somewhere. It's happening. No, because an extract token, I run strip. We should have gotten rid of outer spacing. Once you got rid of the word bearer, it'll have like a space before it. Then you run strip and should get rid of. Yeah, because it'll get rid of the ends of the string, and it'll be just like the token without the bearer will be replaced. Then you run strip afterwards. So I don't know if it's that. So this happens invalid. Let me go back. It occurs here. I want to print out user. Oops. I think this is none. Okay, it is none. So that means it's happening in. I guess I'll print out the token as well. Maybe that is the issue. It's weird. Let me go in my database, open this. Yeah. You can see the passwords here are hashed. There's just a bunch of random letters now. And the session token in the database is not what I've been pasting in. Mhm.
And this security issue in basically the problem and the person stuff, but you know what model you what part of you will use them to interpret the concept, right? And if you know how that model is interpreted the concept, is that a security threat?
Not really. I think it's because like it's a one-way function. So you can have a table of passwords and know how they encrypt or hash into. And that's why we have the salt. So it will modify by a random uh, like prefix so that the table of passwords needs to know that prefix. So having the salt might be also bad. But if they don't know the salt because it's generated randomly, then they can't actually really get anything out of these hashes. Right? So I don't know. One thing is when I log in, I do a renew session. Pick up this up. We go into the table. Looks like it's not updating the database. When you log in. Oh, it's probably because I didn't say db.session.commit. So I didn't save the changes whenever they removed them, I guess. Let me log in again. We try to log out. Okay, that's a better error. So I had to add this session commit when I renewed the session, or else the database wouldn't reflect it onto it. So when I log out, where's log out? This needs to be a colon. Okay, now it should work. So log in, get the token, log out with the token. And now I've been logged out. Okay, really quick, let's get to the last two functions. This one refreshes the session. So let me go here. We're gonna do the same thing. We need the refresh token for this one. So we'll extract the response from this. And we're gonna see if not success. This whole part is gonna be the same as logout. And we're gonna say refresh token will equal response if it is a valid token. So we're gonna try renewing this user session. This will be done using the DAO. It probably says update token on your, if you're using the sample code or the starter code. That's the same thing as refresh token. I'm just using the same terminology from the lecture, but it's just an updating token. And I don't know if we finished this function renew session. We're not renew session. That's the wrong function. Now, this is the wrong function. Let me put this up here. There we go. So in users DAO, let's go to renew session. And so we want to use our refresh token to refresh the session. We can get the user equals the possible user equals get user. And we have the refresh token. So get user by refresh token. And if this user doesn't exist, then this is an invalid refresh token. So I'll raise, this is like a different way to do it, but you can do it in this way. You can raise an exception that's like invalid refresh token. I guess I'd like to show you a different way how to actually do this kind of function. Just doing it in like a try catch block. And then if it's invalid, you can raise an exception. Or you can do it in the different way. Otherwise, you can just say possible user renew session. And then you need to save this, so db.session commit. And then return, one second, return user. Yeah, this lecture is kind of long. We'll do a quick Kahoot and then we'll be out. Yeah, this is how Python syntax. Other questions? Okay. That seems good. So in our here, we'll get a new token or we'll refresh the actual session. If there's an exception, make sure you don't just have like, I guess this down here. Then we return based on dumps or invalid update token, or I guess refresh token. Otherwise, we can just return based on dumps. This is going to be the same thing we've been returning the whole time. This will just be all the new tokens that we made. Yeah, does the reason why we have this function make sense? The whole refresh function? And does it make sense why we like how it's written? This is kind of a different way you can write it. Instead of using the tuples, you can just write like this. And I guess really quick, the last function. This is going to be what you will usually use for like privileged request or privileged endpoints, like posting to your feed or posting a story. You need to be logged in to do these kind of things. So in your final products, if you have these kind of privileged endpoints, you're going to want to get their token like this. So we have a token. You want to see if it's correct. It's the same way we've been doing it for logout. and refresh. So if they have a token and it is in the right format, then we're gonna get the user by users dial. We're gonna get them by their session token. And to be honest, this is the same thing as what logout does. It will get them by their session token. It'll check if that user exists, and also that that token is not expired, so we'll copy that. So all this part, all this stuff up here is just kind of stuff you use a lot for these kind of endpoints that are privileged. This just checks if the token's valid. And after that is just stuff that is endpoint by endpoint basis. So for this one, this will just return JSON.dumps, message, flow, plus user.first name. And the only way that this method or this endpoint will work is if you're logged in and then it knows that you're actually that person with the first name. Did I miss anything? And this will really quick put in curly braces because it's be a JSON. And then I'll probably miss out on testing this refresh. That just gives you a new set of session tokens. And I want to try out secret. So secret, given the session token, running the function. Let's run that. I have my session token in my auth header. I send this. So get request, so into get. And my session token is wrong, which is so unfortunate. I don't even know if it actually is wrong. I might have made a mistake. And copy a new one. And there it says my first name. I forgot to put a space, but you guys get the picture. So yeah, thank you for this nice demo, and we're gonna move into our Kahoot real quick.